Much of what we do in college algebra is going to involve using the real numbers. So we want to start by making sure that we understand what we mean by the real numbers. So starting with our innermost box, this is where we're going to put the natural numbers, or sometimes referred to as the counting numbers, because this is just 1, 2, 3, 4, and so on. And you'll sometimes see the natural numbers denoted with a bold N. So when you see this symbol, that's referring to the natural numbers. Now when we take the natural numbers and include 0, this gives us what we call the whole numbers. And when we take the whole numbers and also include the negatives of the natural numbers, so -1, -2, -3, and so on, this gives us what we call the integers, which we denote with a bold Z. And then the next layer out represents the rational numbers, denoted with a bold Q. And a rational number is any number that I can write as a fraction. So I will represent that as A over B. Now, the thing to notice here is that that means that rational numbers also include the integers, because we could take, say, -5 and turn it into a fraction by putting it over 1. The rational numbers also include terminating decimals, like 0.27 we could write as a fraction as 27 over 100. And it also includes repeating decimals, like 0.3 repeating, you may recognize as 1/3. So any of these types of numbers would also be considered rational. So then that means that the numbers that I cannot write as fractions, that's what's left over for this box over here, what we call the irrational numbers. And based on these examples, what that leaves is the non-repeating, non-terminating, decimal numbers. So a common example for an irrational number is pi. We usually approximate pi as 3.14, but it actually keeps on going forever without repeating, which makes it an irrational number. Another example would be the square root of 2. This is approximately 1.41, but again, it actually keeps on going forever without repeating, which means it is irrational. And in fact, the square root of any number that's not a perfect square would give us an example of an irrational number. And then putting all of this together gives us what we call the real numbers, denoted with a bold R. So anytime we refer to the real numbers, we could be talking about any of the numbers in any of these boxes. So in the example here at the bottom, we're given some numbers that we want to classify. The first one is the square root of 64, which can be simplified into just plain old 8. So that makes it a natural number, and a whole number, and an integer, and a rational number, and then also a real number. -6, this is an integer, which then also makes it a rational number and also a real number. And notice the way that our boxes are set up, once we identify a number as being in one of the inside boxes, it's going to be in every layer from there on out. The next one is the square root of 8. Now, unlike the square root of 64, the square root of 8 does not simplify to a nice, pretty natural number. So this gives us an example of an irrational number. But still, that makes it a real number as well. 9.1, this is a terminating decimal, which means we can write it as a fraction. This would be the same as 9 1/10 as a mixed number, or as an improper fraction, 91/10. But just recognizing it as a terminating decimal tells us that it is a rational number, which then also makes it a real number. 5/8, that one's a little bit more obviously a fraction, which makes it a rational number and then also a real number. And then 0 divided by 7, this is the same as 0, which means that it is a whole number and then also an integer, a rational number, and a real number. Now notice we said that 0 divided by 7 is 0, and in fact 0 divided by any number other than itself is going to be 0. But if we have a number divided by 0, or a fraction with a 0 on the bottom, that we cannot do. So in this case, we would say this number is undefined. This is not a real number, and it does not fit into any of the categories that we talked about up here.